Hi guys, good morning. So my name is Oman. I am the operations manager for our low bay operations in Houston Grand Campus. So I think everyone here is probably familiar with TechnipFMC already, but we work on equipment for oil and gas companies. So we build different kinds of equipment. I'm responsible for the low bay building, which is it's called low bay because it's a lower building, and we work on smaller equipment that basically getting the equipment ready before it goes out to the customer. So we're going to watch a video shortly, and you will see what we do in our low bay building. It's a abbreviated tour of of the building, and you will see some operations that we do on campus and that building specifically. And after the video, you will get a chance to ask questions. And if you see anything that you're not sure of or you want to get more information of, let me know. If I don't know the answer to anything, I might lie. So you will know if I'm lying anyway, so it's okay. So with that, we can go ahead and watch the video now.
Hello everyone, my name is Ty Prince and we are here today at TechnipFMC where I work as a quality, health, safety, environmental, and security program specialist. Today we're going to take a look behind the curtain of TechnipFMC manufacturing. Now let's go meet with Oman, the operations manager.
I am the operations manager for the World Day building. What else do you do?
What do you do?
I manage all operations for the building. I'm responsible for making sure the equipment gets built safely and gets built correctly. Sure. Start here. This is one of our assembly jobs. So this building is top building. Work on we work on different kinds of things like assembly, so we put together items before they get tested. We also work on testing. So what you see here is pressure test cell. So after we assemble the equipment, we do a pressure test to make sure the equipment can withstand high pressure. And typically that will happen in the test cell. We also do things like mobilization, which is getting the equipment ready before it goes out to us. So we do testing, cleaning, setup, make sure it's ready for the customer. We do demobilization, which whenever it gets done, using it out to us, we'll bring it back on campus, disassemble, make sure we know exactly what we need to do before it goes out again. We do preservation, so if something's coming in, needs to stay on campus for a while. Then we have to preserve it, wrapping up sealing areas, plugging up holes to make sure nothing gets permanently damaged before it goes back on store. And then we also do refurbishment. This is the most in-depth thing we do here. So for refurbishment, take it all apart, replace a bunch of new components, replace all the skills, and do a bunch of repair tests.
Awesome.
This is the long assembly area. So typically we'll get long assemblies that look like that. There's a lot of assembly in this assembly area. Whenever that's all that's going, we assemble, and we do some testing. That's our long assembly test point. That's our we put a component in there, fully closed, and within a lot of systems, make sure we can do safety before the while doing our testing. So this is a 6-foot long buffer, 5 here we have our connector actuator tool cell. This equipment is called an upender. It's used to move equipment from the horizontal to the vertical orientation. So to give you an example, this piece of equipment, when it comes in horizontal as it looks right now. But when we actually work on it, we're working it in the vertical orientation. So we use that upender to move it from the horizontal to the vertical orientation. And the reason why it's a lot safer to do it that way, using a crane it takes longer and it's less safe. With this, it's a lot more safe and it takes a couple of minutes to get it done. Okay, so this is a hydraulic flying lead. It's on a reel. It gets rolled into a reel because that's how it's transported. And after that's done, then it gets pressure tested. So this is a pressure testing cell. You have the hydraulic flying lead in the cell, and the cell is to keep it safe, to make sure our personnel, our employees, are not potentially hurt while they're doing the test. These are more just additional wheels that similar to what we just saw in the test cell, but this is where we store them. So that's a better view of a hydraulic wheel. It has a cap at the end where you can apply your pressure, and then you have your wheel rolled around.
Let's go to the office. Graphic design center. Hi, Albert.
Hey, how are you?
Good. How are you doing?
Good.
Tell us who you are today.
Okay, so my name is Malcolm Baker. I'm one of the Rapid Design Center technicians here at the Rapid Design Center.
Yeah.
But what we do here is basically whenever you have a concept, you want to improve your equipment and improve our equipment. Or if you want to maybe start design different pieces of equipment, then what you do is you start at this level here at the Rapid Design Center. You come up with your own concept, your drawing, and then at that point you just want to see if it works. So what you do is you'll take a cheaper material and you'll make that product. So for instance, we have over here is a what they call a CNC shark, and what it's doing is a design has been put into the memory of it, and it's cutting it out through foam. So therefore, you can take that and you can proof it. You can see if it fits together or if it works before you go on to some more expensive material like metal. And we do the same thing with plastic. We also 3D print here. These are a couple of pieces that we 3D printed from plastic. Now these will eventually, some of them will stay plastic because that's what they were intended to do, to stay a piece of plastic. Some of them will actually, once they have passed this process, they'll actually become a piece of metal. They'll look just like that. That's the machine. But it takes more time, more money to do that. You start with plastic first, make sure that works, and then you go on into the metal. And we do the here as well. If you want, we'll go down past our machine shop and then continue on. So this is our machine shop, and basically once everything is made it past the plastic or the foam or the wood stage, now you can go ahead and make that piece out of metal. Because most of the equipment that we use here in our industry is we stand up to high temperature, high pressure, which is going to be your metal. So once those designs are passed on to the machine shop, they can go and take the machine. Once that process is done, we call it annealing. So this is the build phase. Once you have all your parts made, now you can put them together into one larger part. So these are our assembly lanes, our assembly positions. Then, come on over here. these are two of our technicians that are engineering, and basically what they're doing is they're proofing the concept. So once they get everything together, now you have to take it and test it, make sure that it works properly like it's supposed to. In these test cells, we are able to apply high pressure up to, these test cells can go up to 30K, 30,000 psi pressure. As well as you're able to do and do environmental testing, which is basically temperature testing. So we go up to the negative 75 degrees Fahrenheit, all the way up to about 400 degrees Fahrenheit. So we can take these parts and we can simulate a lot of what they're going to be experiencing. On the outside, we need most of these stuff will be the ocean pressure, the ocean floor, the temperature. On the inside, everything that comes out of the earth comes out at very high temperatures and high pressure. So we're bringing both the inside and the outside of these parts. Thank you.
Okay, so tell me a little bit about this lab.
This area is the 3D printing area. This is the RDC lab. This area is where we create some concept prototypes, if you will, quick to failure, quick to find out your design concept works, fix one and function before you go on with your full product design.
So why do we 3D print?
We 3D print because we can show a scaled down model. You can come up with a concept and have it 3D printed in a day or two.
Okay. Awesome. So we do this to save time and money when we're making. Awesome. Thank you so much. Okay, so tell me what your job is here.
My job is 3D printing. I also work on CNC stirrup. We've got to clean the parts. Sometimes we assemble them. Really all design and prototyping for any needs of the RDC or our customers for the RDC.
Okay. And how about you? What's your job here? Awesome. So this is a 3D printer?
Yes, this is a 3D printer.
Awesome. And so what does the 3D printer do?
This will build up layers, like if you think of a traditional printer that puts ink, this lays the color and model material.
Okay.
And it will keep building layers up to whatever your design needs are.
Okay, great. That's awesome. Not looking into the light.
This printer here is a polyjet printer.
Okay.
And it's a liquid resin. It runs on cartridges that fill in there that are filled with 3D print material.
Oh, okay.
So it will actually it'll spray almost like spray paint.
Oh, cool.
So each layer is 0.0006 thousandths at a time, and it'll continually build up like if you were to look at a stack of papers, like right here. Each time it goes down, it lays a layer. So you're laying a stack of paper, another paper, and pretty soon as you stack them all up, then you can get a 3D print like this, and it shows your whole design.
So this is something that you all 3D printed here?
Yeah, we 3D printed this here.
Wow.
This has been professionally coated, and this would be a deluxe 3D print. Modular, meaning you can take it apart.
Oh, wow.
Put it back together, change where the valves fit in, do new concepts.
So how long does it take to build a model like that?
To build a model for this took about a week of design time, and it took another week and a half to 2 weeks to 3D print it, with another week to coat it.
Okay,
We
great.
had another vendor coat it, but we did all the 3D printing here on the 500 right there.
Awesome.
Yeah, so we came up with this design and we modeled it in 3D. This is basically what's gonna come out of it.
Okay.
We start with a foam or a solid block of foam or even wood.
Okay.
Wood. We get it into paper or 3D, and we basically have the machine to carve out this shape, and we get an elementary tool of this. So this particular thing we did was to organize our tools better in the shop. So this represents the cutouts done by the machine.
That's
So
awesome.
it's like carving like a pumpkin. Same thing. You carve out the shape that you want. So we do the same for the tools.
Awesome. Thanks so much.
Awesome.
Thank you, Omar, for showing us the operations here at Grand Campus and a look behind the curtain. We appreciate your time. And hopefully all of you enjoyed the look behind the curtain as well.
Thank you. Thank you for coming out here. It's always good to show off.
Thank you. Well, I hope you enjoyed your look behind the curtain of TechnipFMC Manufacturing.
All right, Oman. It looks like we've got some questions coming in. So
Okay.
everyone, please don't forget to ask your questions in the Q&A section right above, and we'll get those asked to Oman. So one of the first questions is, how much does it cost to buy a 3D printer?
Okay, so it depends on the 3D printer. We have different sizes of 3D printers. So for the ones you saw out in the shop, the bigger ones, it's closer to about $20,000, some even more than that. For a small 3D printer that you want just for your home or for the office for small prototype parts, it's about $5,000.
Okay. Here's a question that I know you'll know. What is the difference in helmet colors?
Okay. Oh yeah, that's an easy one. It's a good one though because that's our safety. That's how we look out for safety for everyone. So the white helmets are for long-term employees that have been with the company for a while that are very familiar with the operations going on in the workshop. So typically, if you see a white helmet, then you're pretty safe to know this person knows what's going on, and you don't have to be too much on the lookout. The orange hard hats are for new employees. So if you've been with the company for 6 months or less, and you have to wear an orange hat, so everyone knows that you're still somewhat new and can be on the lookout in case you're doing something that requires some supervision. The red hard hats are for our ERT, Emergency Response Team members. So we have a team of employees that take a bunch of training to make sure they can respond for emergency type situations. So they get like resuscitation training, first aid training, and they all have first aid kits that they keep with them. So if someone gets hurt, they call a number, and all the ERT members get a call, and the first to get a call rushes to the area. The yellow hard hat, which Ty should not have been wearing, but that's for visitors. So typically, if we have a customer that's coming in for a tour or just visiting the campus, they would have a yellow hard hat. And the last one, a couple of other ones, but you may see a blue hard hat, which is for all of our lead technicians. You may see a gray hard hat, which is for our supervisors and managers for the shop floor. So that's all the helmets that we wear on the shop floor.
Awesome. Thanks for that answer. Okay, so another question. Can you 3D print with metal or other materials?
Yes, you can. It depends on the kind of 3D printer. Now, if you buy a $5,000 3D printer for your home, you will not be able to print with metal. That's usually just not plastic, but plastic type stuff for prototypes. For the larger ones, you can print some small metal parts. And for those, then you can actually use them to test on the shop floor to see does it fit what you're trying to do. But you would have to get a bigger, a little more expensive 3D printer to print with metal.
Okay, great. So these next two questions are actually somewhat related. The first question is, do you have to be a special kind of engineer to design on these machines? So I think they're referring to the CNC machine and the 3D printer.
Well, so the 3D printer is actually to print a prototype of a design that's already been made. So I don't know that it necessarily takes a special engineer. The designs are created basically in the office, knowing the equipment. You make a design of something that you think is going to work, and then the reason why you 3D print it is to print a prototype to make sure you can do a fit test and make sure that it's going to work. So it doesn't necessarily take a special type of engineer. Most of the engineers we have that work at the company, we have mechanical engineers. I think they mostly do the mechanical type designs. We also have some industrial engineers. They help with process type things. We have electrical engineers that help with the offshore electrical type operations. But most of the design type stuff is mechanical engineers.
Okay. And then the next question that relates to that is, what was your educational path? How did you get here?
It's a good question. A mechanical engineer by trade. So I tell people I'm a recovering engineer. And what I mean by that is I don't really do as much engineering anymore. So I do more operations management and people management. I would say my passion now is managing people, but my background is mechanical engineering. So I did some mechanical type designs when I started with the company. I've done some system type designs. I've done some process designing. But my background is mechanical engineering, and I've worked in the different areas from design to pressure testing to assembly. I've been taught some courses on how to create procedures, and then I've done offshore installation type engineering, and currently I doing more operations management, so more managing the hands-on type employees.
Okay. And I think you somewhat answered that question, the next question that came in within your last answer, but maybe you can elaborate more. What is your favorite thing about what you do?
Oh yeah. Um, right now my passion is the people. I love managing people. I think there's nothing that brings me more satisfaction than you get a new employee, you see them struggling with something, you don't give them the answer, but you work through it and help them come up with the answers. So it's very rewarding when you see someone that goes from being a new employee to being the most confident employee on the shop floor. It's very rewarding. My favorite thing I would say is it's a balance of the interaction with the people all day. I would say the strongest thing about TechnipFMC is our people. We have really good people. It's like a family, honestly. I don't feel like I really work. I know I shouldn't say that out loud because people are saying, "What are you doing here then?" But I don't feel like I work, honestly. I feel like I go to work, in quotes, and I just hang out with people that I love to work with. We work through problems together. And also, I like the hands-on type stuff. So I can walk out to the shop floor and physically see the equipment. Whenever we have issues on the shop floor, I don't have to get on the call and ask questions without seeing what the equipment is. I can actually walk out there, put my eyes and, if needed, put my hands on the equipment and help troubleshoot issues. So I would say those are my two favorite things: is the people and the fact that the equipment is right there. We can all troubleshoot together in front of the equipment, seeing it physically.
Okay, so we had another really good question come in. It looks like Technip FMC builds really big things. What is the tallest or longest thing?
That's an issue. Yes, we build very big things. The largest equipment I know of that we've made in terms of weight is about 180,000 pounds. So
Oh, wow.
that's a lot of weight. It's pretty large. As far as the height, it's dependent on how you use it. So like if you, when we're doing the when you saw the tour on the shop floor, those things that were sitting horizontally on the ground, those are about could be as long as 50 feet. But when we actually use those are used in a vertical orientation. So that's about 50 feet tall when you actually use it offshore. When we work on it on the shop floor, we work on it horizontally just because it's easier to do it that way. You can get access to all of the different parts of it. So from a height standpoint, I would say 50 feet is the longest we do in low bay. In high bay, which is our tall building where we work on the big equipment, when you stack those up, then you're getting even more than 50 feet. You're getting very tall with those because you're stacking up four different things that are all anywhere between 10 and 20 feet. So it's all very large equipment, but in low bay, the longest we do is about 50 feet.
Okay. So another question came in, which actually you probably can also answer. So this helps get oil out of the ocean, right? How do the things that you guys work on help with getting oil out of the ocean floor?
So it's the equipment we actually looked at today. The first one, if you remember the tour, the first part when we saw the valves that get tested in the test cells, those are actually valves that eventually those kinds of valves get built onto what we call a Christmas tree. So if you've been to the campus on STEM day before, we've looked at the high bay where you see Christmas trees with a bunch of valves. Those are the actual things that sit on the ocean floor, and it's pretty much your first barrier whenever you start producing. So you ask about oil coming out of the ground. If you think about the seabed, you have your sand, let's say sand on the ground, and you have a wellhead that sticks out of the ground. So the wellhead is pretty much your stem, your stump, whatever you want to call it. The Christmas tree sits on top of that. If I'm describing the Christmas tree to someone that's not as familiar with the equipment, I say the tree is pretty much like a big, fancy, expensive faucet that you turn on and off whenever you want to produce. So let's say your tree is installed on the wellhead. When you want to produce, you turn on your faucet and quotes, and then that's basically opening up a valve. So you open your valve, and that allows your flow to come from below the seabed. So it goes into your tree. And then there's a series of valves, a bunch of valves, and there's a choke that you can use to control the rate at which you let the oil out. And eventually, when it goes through the tree and you can check the properties, it checks the temperature, checks how much sand and all that. We have a flow meter that monitors all of that stuff. When it gets out of the tree, that's when it gets in your flow line and then it starts going up to your ships and everything like that. But the Christmas tree is your first barrier, it's your first line of defense, it's your first faucet, if you will, that gets open and closed to allow that oil to come out of the ground.
Okay. And what about the really tall one that you guys were in front of?
That's for trying to think the best way to describe that. That was a tool to function a valve. That wasn't really for production per se. So we have the big connector that was underneath it. That connector is used for the flow line, and it's used to connect one piece to another piece. That's to help you lock and unlock it, and also helps you control your well. So if you see there were three different layers of valves, if something happens and you have to like quickly shut off, that also helps you do that.
So that's a safety piece that helps prevent spilling.
It's a safety piece that helps prevent spilling. It's almost like similar to what a BOP does, but not quite a BOP. A BOP is a lot more complicated, but similar, yes. And a BOP is a blowout preventer, by the way. It prevents a blowout in the field.
Okay, great. And we've got another question here. It looks like it takes a lot of time to build. What's the average time of the things you build?
It depends. So we have some things that literally come in the shop and they're done within a couple of hours. So those are the simplest things. In low bay, the most complicated thing we have is a tubing hanger. So that's what holds all your tubing, 10,000 feet of tubing that goes all the way to the oil. That when you build it brand new, the overall pressure testing and assembly takes about a month and a half. A Christmas tree, if you're building a Christmas tree from scratch, start to finish, takes about 3 months for the assembly and the test. So it depends on the equipment. Some are more complicated, some are simpler.
Awesome. Okay. If there's anybody else got questions, it looks like that's all the questions that we have thus far. We'll give it a couple more minutes. In the meantime, thanks so much, Oman, for that tour of the low bay. Very interesting information. Don't forget for the participants that there's a LinkedIn link in your digital program to view Oman's information and learn more about his journey. And if you have additional questions, please make sure that you're posting them so that we can get those questions answered.
No, thanks. It's always fun doing this. I like showing off our campus. It's a great campus, and I like talking about the company because I really do like what I do here.
Well, we're back. We got a really good question asked just at the last minute, so we figured we'd pop right back in. Oman, this question says, what should I study to work in a place like this?
It's a good question. So I think one of the great things about TechnipFMC is we do everything from the start to the finish. So we get the order from the customer and all the way through to actually deploying it in the field. So there's so many different things you can study to work at a place like this. Now, if you're asking from a technical standpoint, any engineering field, you can probably work at TechnipFMC with any engineering background. But also we have everything from we have a finance department, we have a safety department, we have engineers that do electrical stuff, we have industrial engineers, we have it's pretty much whatever you study. I would say we care more about the people and the values of the people, and there's probably a place for most people within the company. But as far as the technical, I would say any of the engineering or industrial engineering, industrial distribution, any of those fields will work. But also, like I said, finance, project management, those work as well.
Okay. That's a great answer. I would echo that. Project management is where I started, and I ended up in IDS. So I think there's an opportunity for every type of background at TechnipFMC.
There really is, yes.
All right. Well, thank you, everyone. And again, if you have questions, please feel free to post them in the chat, and we will get them all answered before the day's over.